Why do some species glow in the dark? The ocean at night is a cathedral of black water, and yet, here and there, tiny lanterns drift in the depths. They are alive, and they carry light inside them, as if the stars had chosen to hide in living bodies instead of the sky. Why, in a world so vast and dark, would life choose to make itself shine? Settle into the quiet now, and let's drift deeper. Together, we'll explore why some species glow in the dark, from glowing waves at the edge of a moonlit beach, to silent hunters with lamps in the abyss, to fireflies sending love letters of light through summer air. If you enjoy these softly told science journeys, take a moment to like this video, subscribe to The Thoughtful Night, and tell me in the comments where in the world you're listening from tonight. I read everyone. Now, close your eyes, slow your breathing, and imagine the lights of the room fading away until only the lights of nature remain. Long before forests stood on land, before birds sang, before even fish swam in seas, the earth was a very different place. The continents were bare. The air carried no human voices, no bird calls, not even the hum of insects. The oceans ruled the planet, vast, deep, and mostly dark. If you could drift back billions of years, the nights over those ancient waters would have been unlike anything we know. No city lights, no ships at sea, not even the soft glow of a lighthouse. Only the moon's pale reflection and the quiet shimmer of stars above. And yet, if you looked closer into the black water itself, you might see something faint. A flicker, a ghost of light moving just beneath the surface. These were the earliest glowing life forms, not fish or jellyfish, but tiny, single-celled organisms. Primitive bacteria drifting in the currents, carrying inside them the first sparks of what we now call bioluminescence. Their light was not fire. It was not heat. It was a cool, silent shimmer, like the faintest star seen through mist. No one knows exactly why the first flickers began. Perhaps it was an accident, the byproduct of ancient chemistry. Inside those tiny cells, oxygen reacted with certain molecules, releasing energy in the form of photons, little packets of light. At first, it might have served no purpose at all, just a chemical curiosity in a young, restless ocean. But in nature, accidents sometimes become advantages. That dim light, so weak you might not even see it unless you were very close, could have frightened away a predator that preferred complete darkness. Or it might have helped the tiny organism cope with oxygen, which in those early times was a dangerous new element in the environment. Over millions of years, what began as a side effect of survival could have evolved into a deliberate, controlled glow. Imagine it. A moonless night. Waves rise and fall in the open sea. The world is silent except for the slow rhythm of water moving against water. And then, a thread of light, barely there, passes under you. Then another. It is not constant like a lamp. It comes in brief pulses, soft and slow, like a heartbeat you can see. These glows were not random. Even among the earliest microbes, there may have been patterns, a natural rhythm to when the light appeared. The ancient sea at night might have looked, in miniature, like the sky, dots and clusters of light suspended in blackness. Over time, these glowing bacteria became part of a much larger story. They spread through the oceans, drifting with the currents, sometimes living on the bodies of other creatures. In the dark belly of the sea, they created living constellations. And just as starlight travels through the vast emptiness of space, their light traveled through salt water, touching anything nearby with a pale glow. This was the first language of light and life, though no one was yet there to witness it. No eyes had evolved to see it. No minds existed to wonder at it. The glow was simply there, part of the Earth's quiet breathing. Billions of years later, that same basic chemistry, the transformation of chemical energy into light, would appear again and again in species far more complex. Some would use it to lure, others to hide, others to call to one another across the dark. But here, in this first chapter of the story, there was only the ocean, the darkness, and the faintest sparks of life's light. The ancient seas were not like ours. The waters were thick with microscopic life, their shapes simple but their chemistry already astonishing. With no plants on land to hold soil in place, rivers poured minerals into the sea, feeding blooms of bacteria and plankton. And in this rich, crowded soup, glowing life had a place to thrive. At night, the surface waters could have glimmered when stirred, as each tiny organism released a short pulse of light in response to movement, the same way some plankton still do today. The effect would have been mesmerizing, a wave's crest curling into a soft, blue-green shimmer before collapsing into blackness again. Scientists think that the ability to glow may have evolved in multiple species separately, meaning it wasn't just one lucky ancestor that learned to make light, but many. In different corners of the sea, under different pressures of survival, different microbes stumbled on the same idea: light could be life. And so, the darkness of the ancient ocean was never complete. It was never absolute. Even on nights when clouds hid the moon, the sea itself could whisper light back into the world. Think about that for a moment. Before there were eyes to see beauty, beauty still existed. Before there were minds to understand it, light still bloomed in the dark, a secret between the ocean and itself. As the ages passed, the glow became part of the deep's identity. Larger organisms evolved, and some formed symbiotic relationships with the glowing bacteria, carrying them in special light organs. Others developed their own light-making chemistry. What began as the flicker of single cells spread into a language used by hunters, lovers, and wanderers of the sea. And yet, that first flicker matters. It was the spark that lit a path millions of years long. Without it, the fireflies' dance, the jellyfish's pulse, the anglerfish's eerie lantern, all might never have existed. Tonight, as you picture that black, ancient ocean, imagine it from far above, like looking down from a cliff into eternity. The water shifts slowly, silently. Here and there, a shimmer moves, so small, you almost think your eyes are playing tricks on you. But they are not tricks. They are life, breathing light, the very first breath of it. Now, we will follow that light forward in time, through chemistry, through evolution, into the many ways nature has learned to shape darkness with color. In the next chapter, we'll go deeper into the soft alchemy that makes bioluminescence possible at all, and why it is not fire, but the memory of stars stored in living cells. The glow begins in silence. Inside the body of a living creature, whether a drifting bacterium or a deep-sea jellyfish, there is no spark, no flame, no burning heat. And yet, in a tiny chamber within a cell, a slow, invisible dance unfolds. The heart of this dance lies in two partners, luciferin and luciferase. Their names sound like something from an old myth, and in a way, they are, because they carry the story of light through life itself. Luciferin is the molecule that makes the glow possible. Alone, it is quiet, patient, holding potential like a lantern without a flame. Luciferase is the enzyme, the match, the hand that strikes it. When the two meet, in the presence of oxygen, they transform chemical energy into light. It is not fire. It is not heat. It is something gentler, what scientists call cold light. Almost all of the energy goes into the glow itself, not into warmth. If you could touch the place where the light was born, it would feel no different than the rest of the body. This reaction, luciferin, luciferase, oxygen, is like a secret recipe repeated across the tree of life. But here is something astonishing. There is no single, universal luciferin. Different creatures have evolved their own versions, each with its own structure and color. Some glow blue, some green, some golden. In the deep sea, blue is the most common, because blue light travels farthest in water. But on land, among fireflies and glowing fungi, green and yellow are more common, colors that shine beautifully in air. Think of it as nature composing the same song in many keys. The melody is the same, light born from chemistry, but the notes, the shades, the timing are unique to each performer. For a creature to make its own light, it needs more than just the chemical ingredients. It must have the ability to control them. Many bioluminescent animals store luciferin and luciferase separately, keeping them apart until the right moment. Then, in a fraction of a second, they mix, and the glow blooms like a flower opening in the dark. The glow can be constant, like the steady lantern of an anglerfish, or pulsing, like the rhythmic flashes of a firefly's courtship dance. It can flare in panic, fade in patience, or blink in complex patterns only members of the same species can fully read. In some cases, the creature doesn't make the luciferin itself, it borrows it from something else. Certain fish and squid host glowing bacteria inside special light organs, feeding and protecting them in exchange for their light. In these partnerships, the chemistry happens inside the bacteria, but the larger host uses that light for its own purposes, to lure, to hide, to communicate. The physics of bioluminescence is as elegant as its chemistry. When luciferin is oxidized, that is, when it reacts with oxygen, electrons in the molecule absorb energy and move to a higher state. When they fall back to their original state, they release that energy as a photon. One particle of light, born in darkness, traveling outward into the surrounding world. And because this light is so efficient, it can shine brightly even in the cold, crushing pressure of the deep sea, where energy must be carefully conserved. Scientists sometimes call bioluminescence a living flashlight, but that phrase feels too sharp, too mechanical. It is closer to a living candle flame, though even that is misleading, because candles burn and heat the air, while this light glows without loss, without waste. I like to think of it as the memory of stars stored in living cells. After all, the energy in every chemical bond on Earth comes, in some way, from sunlight, from nuclear fires burning in the heart of our star, filtered through the long story of life. The glow of luciferin is not sunlight itself, but an echo of it, turned inward, transformed, and released again in the quiet. When we see a glowing wave on a beach at night, or a single firefly hovering in a summer meadow, we are not just looking at a beautiful accident of nature. We are looking at a process so deeply refined by evolution that it wastes almost nothing. A human light bulb might waste most of its energy as heat. A bioluminescent cell uses almost all of it for light. And this efficiency is not just elegant, it is vital. In the deep sea, where food is scarce, every joule of energy counts. To waste it would be to risk death. That is why natural selection has made this glow so perfect, so silent, so cold. Some species can even choose the color of their light. Certain deep-sea shrimp can shift the wavelength of their glow by altering the proteins around the luciferin. This ability to tune light is like painting with a chemical brush. Others, like the Hawaiian bobtail squid, hide their glow in the daytime, only revealing it when darkness comes. They do this not for beauty, but for survival, matching the glow of the moonlit surface so that predators below cannot see their shadow. But all of this, all the patterns and colors and tricks, rests on the same foundation, a molecule, an enzyme, and oxygen, dancing together in a darkness that they themselves illuminate. In a way, bioluminescence is the most poetic of chemical reactions. It doesn't roar like combustion, doesn't churn like fermentation, doesn't hum like electricity. It simply appears, silent, cool, and perfect, a little pulse of starlight inside a living body. And the first time it happened, in those ancient seas we visited in the last chapter, there was no one to see it but other drifting cells. And yet, the chemistry endured. It was passed from one generation to the next, reshaped, adapted, refined, until today we find it in creatures that swim, crawl, float, and fly. It is a reminder that nature's most beautiful tools are often born in simplicity. A single chemical reaction, repeated billions of times, can change the way an entire world looks at night. And now, having learned how the glow begins at the smallest scale, we can step out of the cell and into the world it lights. In the next chapter, we will leave the laboratory of the mind and drift into the living ocean, into waters alive with waves of blue fire, drifting jellyfish, and trails of light that follow every movement. The ocean at night can seem like emptiness without edges. No horizon you can see, no floor you can feel. Just the sound of water moving against water, the hush of a planet breathing in slow tides. But if you wait and let your eyes adjust, the darkness begins to change. At first, it's only a suggestion, a slight shimmer where the tip of a wave folds over. Then, as the water rolls, a faint blue light trails behind. Another wave breaks farther out, and for a moment the sea glows as if moonlight had seeped up from below instead of shining down from above. This is bioluminescence made visible on a grand scale, not in the cells of a single bacterium, but in countless trillions of microscopic plankton drifting near the surface. Most of them are dinoflagellates, tiny single-celled organisms that have mastered the art of glowing when disturbed. Each one is invisible to the naked eye, but together, they can turn the sea into liquid light. A single step into the shallows can leave a glowing footprint. The path of a swimming fish can become a trail of stars that fades only after the water settles again. Why do they glow? For many, it is a defense. When a predator brushes against them, they flash, and in the deep, sudden light can be startling. Some scientists think the flash might act as a burglar alarm, drawing larger predators to eat the first predator, giving the plankton a chance to escape. Others think it may simply confuse attackers, a quick burst of light followed by sudden darkness. Whatever the reason, the effect is hypnotic. In warm coastal waters where these plankton bloom, entire bays can shimmer when stirred. A kayak paddle turns the surface into glowing ribbons. A wave breaking on the sand looks as though someone poured blue fire into it. In Puerto Rico, in the Maldives, in parts of Australia, people travel just to witness this phenomenon. But not all ocean light comes from the surface. If you sink deeper, past the last reach of sunlight, a new kind of night begins. Here, at depths of hundreds or even thousands of meters, bioluminescence is not rare, but common. In fact, scientists estimate that the majority of deep-sea animals can produce their own light. Picture yourself drifting here. It is silent, except for the slow drift of your own body in the current. The pressure is immense, tons of water above you. And in the dark, lights appear. Not steady, but scattered. A faint pulse in the corner of your vision. A slow sweep of green from something too far to see clearly. Little points of blue and white drifting like slow-moving stars in a black sky. Some belong to jellyfish, their bells expanding and contracting in silence, sending pulses of light like a heartbeat through the water. Others are siphonophores, colonial creatures made of many smaller units that can form glowing chains tens of meters long. There are shrimps and small fish whose undersides glow softly, matching the faint light from above so predators below cannot see them. And then there are the hunters. In the gloom, you might see the glow of a small lure swaying back and forth, attached to the head of a fish waiting in stillness. This is the anglerfish, one of the most famous deep-sea predators. Its lure is home to glowing bacteria, and it uses this false beacon to draw prey close enough to strike. In the open darkness, a point of light is impossible to ignore. It might be food, or a mate, or safety. But for the anglerfish's victims, it is the last thing they ever see. Elsewhere, flashlight fish cruise with two bright spots under their eyes, not electric lamps, but light organs filled with bacteria. They can open and close a flap of skin to hide or reveal the glow, flashing patterns to communicate or hunt. In some places, the light is not constant but sudden, an eruption. Certain jellyfish, when disturbed, can light up their entire body in a sudden bloom of color, as if becoming a living lantern. This may startle predators or even attract bigger hunters to attack whatever disturbed them. What is most striking about these deep ocean glows is not their brightness. They are often dim compared to artificial light, but their isolation. Each light seems alone in the blackness, yet together they form an ever-changing constellation. There is no fixed map here, no North Star, only drifting lights that come and go. Scientists studying the deep ocean sometimes describe it as an endless night sky turned upside down. The creatures are the stars, but unlike the heavens, they move with purpose. Their lights blink and fade, trail behind them, flare in warning, or guide them to food. And while the deep ocean holds the majority of bioluminescent species, even the open waters between surface and seafloor can shimmer with life. Schools of fish can glow faintly along their flanks. Shrimp can release glowing clouds to distract attackers. Squid can spray bioluminescent ink instead of dark ink, creating a glowing phantom in the water while they escape into the dark. If you could watch the ocean from above at night, not just the surface, but all its depths at once, you would see a living galaxy. Millions upon millions of points of light, each born from a cell or an organ, each serving a purpose. Some are steady as the tide. Others flare for a moment and vanish forever. And yet, despite this abundance, much of it remains hidden from human eyes. The deep sea is difficult to explore, and each new expedition reveals more glowing species we've never seen before. Some scientists believe we've only found a fraction of the forms bioluminescence can take. The truth is, the oceans have always been glowing, long before we could see them, long before we thought to ask why. The waves that curl on a beach at night, the silent hunters of the abyss, the clouds of glowing plankton drifting with the currents, they are all threads in the same fabric, woven from chemistry, evolution, and the timeless pull of darkness toward light. And as we leave this glowing seascape behind, our journey moves to the next layer of the story, not just how light appears, but how it speaks. For in the next chapter, we'll see how marine animals use their glow to send messages in the dark, to attract, to warn, and to signal across distances where no sound can travel far. In the deep ocean, there is no sunlight to catch in the eyes, no shadows to gesture with, no colors to wave as flags. Here, communication must be written in light itself. For many marine species, bioluminescence is language, a language of pulses, flashes, and glowing patterns that can be read only in darkness. Every flicker carries meaning. Come closer. Stay away. I am here. I am dangerous. I am yours. It begins simply. In some fish, a slow, steady glow along the belly tells others of the same kind that they belong together, a silent group identity in a world of strangers. In others, flashes from specialized light organs act as a kind of underwater Morse code. A flash, a pause, two flashes, a message only those who share the same code can understand. Consider the deep-sea squid. Some species have hundreds of tiny photophores, light-producing organs, arranged in patterns across their bodies. They can brighten or dim different patches, creating moving designs across their skin. To us, it might look like a drifting constellation. To another squid, it might say, "I'm ready to mate," or "This territory is taken," or even "danger nearby." For some squid, the communication is more dramatic. When threatened, they might release a burst of glowing fluid, a cloud of light that swirls in the water, then vanish into the black. The light is both a distraction and a signal to others. Predator here, beware. This dual purpose, speaking to friend and foe at the same time, is one of bioluminescence's great strengths. In a place where sound travels slowly and murkily, light is instant and unmistakable. Then there are the flashlight fish. Under each eye, they carry a pouch of symbiotic bacteria that glows softly blue-green. A thin lid of skin lets them open and close this light like a shutter. In the still water, they can blink in rapid patterns to signal to their school, helping them stay together in the dark. To us, it might look like random twinkling. To them, it's a coordinated dance. Some fish use this language to hunt in pairs or groups, flashing signals to guide one another toward a school of prey or to surround it silently. In these moments, light is not just beauty, it's strategy. Not all messages are meant for allies. Some are meant to lure. The female firefly squid in Japanese waters rises toward the surface at night, her tiny photophores glowing like a net of stars across her body. To plankton, this moving constellation might look like scattered food particles reflecting light. Drawn closer, they swim into reach and become her meal. There is also the matter of courtship. In the deep ocean, finding a mate is no small task. Populations can be sparse, individuals spread across wide distances. A specific flash pattern can mean "I am your kind." A different rhythm can mean "I am ready now." In some species, males and females flash and call in response, their lights answering each other until they finally meet in the dark. Perhaps the most mesmerizing example comes from the ostracod crustaceans of the Caribbean. Males create a trail of tiny glowing spheres in the water, like a dotted line leading from the seabed upward. These light beads hang suspended for a few seconds before fading, but by then, the pattern has been seen by potential mates. To witness it is to see a silent poem written in light. This ability to encode meaning in light is not confined to complex animals. Even some plankton can respond to the approach of others with bursts that ripple across a bloom, creating wave-like flashes. To us, it's a beautiful spectacle. To them, it may be the difference between attracting a mate or escaping a predator. The rhythms of bioluminescent communication are often as precise as any bird's song or insect call on land. Some are timed to the lunar cycle, flashing more intensely during certain phases of the moon. Others are tied to tides, water temperature, or the time of night. It is a choreography of light, synchronized with the ocean's larger rhythms. Imagine drifting among these conversations. To the human eye, they seem like random flickers scattered through endless dark. But if you could read their meaning, you would see entire dialogues unfolding, introductions, warnings, seductions, all without a single sound. Light can also be a bluff. Some species mimic the flash patterns of others to confuse predators or lure prey. This is risky. If the imitation is not perfect, the deception fails. But in the vast deep, where encounters are brief, it can be enough to survive. And then there are those who speak by not glowing. In some situations, switching off the light is its own message. I am hiding now. Silence and light, like silence and sound, can be as loud as any signal. Bioluminescent communication is fleeting by nature. A flash is gone in an instant, a glow fades quickly. It leaves no trace, no footprints, no scent, no echo. Only the memory of light in the eye of whoever saw it. This is part of its power. In a place where predators might follow any lingering signal, vanishing into darkness is as important as appearing in it. What strikes me most is that these messages are carried by the same chemical process we explored in the last chapter. Luciferin, luciferase, oxygen. That tiny, quiet reaction becomes the medium for entire languages, shaped by evolution for purpose and beauty alike. We humans can't truly join these conversations. We can only watch and wonder and try to understand a few of the meanings. But in a way, just witnessing them is enough. To see light moving through darkness is to know that even in the most silent, isolated parts of the world, connection exists. And as we leave these conversations behind, we turn toward another side of the story, not the friendly messages, but the predatory deceptions. In the next chapter, we will descend once more into the deep, to watch as hunters use light not to speak, but to lure. In the deepest reaches of the sea, where no sunlight has touched for millions of years, the darkness is not empty. It is patient. It is waiting. And within that waiting, a few creatures hold their own tiny lanterns, turning the blackness into a hunting ground. Here, predators are not built for speed alone. They are built for stillness. Their bodies are often slow, conserving precious energy in a place where meals may come only once in weeks. Instead of chasing prey, they summon it. And for this summoning, light is their silent accomplice. Imagine the anglerfish, perhaps the most iconic of these deep-sea hunters. Her body is wide-mouthed and shadowy, built for swallowing creatures nearly as large as herself. But it is the rod jutting from her forehead, tipped with a pale, glowing lure, that defines her. Inside that lure live bacteria, her permanent light makers. They glow not for themselves, but because she offers them a home, a constant shelter in exchange for their luminescent gift. She dangles them in front of her, letting the faint light sway like the memory of a drifting worm. To an unsuspecting fish in the darkness, that glow is not a warning. It is a promise of food. And so they swim toward it, until the dark closes over them again in a single, swift bite. The patience of the anglerfish is not unique. Far above, but still deep below the waves, the flashlight fish patrol the darkness in a more deliberate way. Beneath each of their eyes sits a small pouch filled with light-producing bacteria. They can open or close this pouch like a tiny eyelid, turning their headlamps on and off. In hunting, they flash their lights to confuse schools of smaller fish, darting in with quick precision. The beams ripple through the water, making it impossible for their prey to tell where safety ends and danger begins. Other hunters wield light as a kind of trap without walls. Some jellyfish, for example, do not just glow, they pulse. The rhythm of their light travels through their tentacles like a soft heartbeat, drawing in curious plankton and small fish. But in touching those drifting threads, the prey is instantly stilled, caught in the quiet grip of stinging cells. And then there is the dragonfish. Sleek, almost blade-like, it carries its light not only in a lure but along the sides of its body. Some species even shine red, a rare trick in the deep, where most animals cannot see that color at all. In this way, the dragonfish hunts in a kind of private spectrum, invisible to all but itself. With red light, it can illuminate prey without revealing its presence, a predator's dream, to see without being seen. In all of these hunters, light is not decoration. It is a tool honed by necessity. In the deep ocean, vision is a rare gift. Eyes are large, hungry for photons, ready to detect even the faintest shimmer. A single spark is enough to change the course of the night. For the predator, that spark means dinner. For the prey, it might mean danger, too late realized. Yet in this place, the balance remains delicate. Too much light, and a hunter may give itself away to a larger predator. Too little, and the bait will not be convincing. Nature has tuned these lights with the precision of a master craftsman. Not too bright, not too dim, just enough to tempt. Picture, for a moment, floating there yourself. You are suspended in the black, your breathing slow, your body drifting with the faint swell of unseen currents. Somewhere in the distance, a small point of light sways, as though it has noticed you. It grows brighter, moving in a gentle rhythm, almost hypnotic. The darkness around it makes the glow seem all the more alive. You find yourself leaning toward it, unable to resist knowing what it is, until something moves just beyond the light, and you realize you were never alone. The stillness of these hunters is perhaps the most haunting part. They are masters of patience because time here moves differently. Without sunlight to mark hours, without seasons to shift the temperature, the deep sea is an eternal night. In that night, every encounter is magnified. A single flash might be the difference between hunger and survival. There is also an elegance in the way the prey and predator play this game. Some prey have learned to avoid certain glows. Others have developed ways to spot the faint outline of a predator hiding behind its light. Evolution, here, is a constant whisper of adjustment, a new trick, a new counter, a new refinement. But the dance remains the same. Light is both the call and the snare. From above, where we stand in our well-lit world, it might seem strange, using beauty to kill. But in the deep, beauty and danger are rarely separate. Light is simply another currency of life, traded in different ways. For the hunters, it is an investment. Each glow cast into the darkness is a gamble that something will notice, approach, and give itself away. And perhaps there is a quiet poetry in knowing that in the most remote places of Earth, the act of survival can look like a lantern swinging gently in the dark. Here, far from the sun, life has learned to carry its own day, and to use it with deadly precision. Now, from the predator's glow, we drift toward another kind of light. Not the lure, not the trap, but the vanishing act. Creatures who shine not to be found, but to disappear. The ocean at night is a place of layers, not just of water, but of light, or the absence of it. From the inky blackness of the abyss, one can look upward and see a faint silver glow filtering from far above. It is moonlight, starlight, sometimes even the reflected shimmer of clouds. It is thin, diluted by leagues of water, but it is still there, a soft, heavenly veil drifting down into the deep. In these dim spaces, glowing is not always about being seen. Sometimes, it is about not being seen at all. This is the art of counter-illumination, the quiet trick of matching the faint light above so perfectly that a predator below sees nothing but the seamless outline of open water. Imagine a squid, suspended halfway between darkness and dimness. It is aware, in the deep instinct of its body, that something larger might be looking up. And so, it switches on its underside lights, tiny, calculated glimmers, not brighter than the water above, not dimmer, just exactly right. In this moment, the squid becomes an echo of its surroundings, a ghost in the water. The biology behind this disguise is precise. Many of these creatures house symbiotic bacteria in small light-producing organs along their bellies. The squid provides the bacteria with a safe home and nutrients. In return, the bacteria produce light. But light is a dangerous gift, too bright, and it betrays you. So the squid can dim or brighten it, adjusting for the moon's phase, for drifting clouds, for the shifting brightness of surface waves. It is camouflage by calculation, practiced every night in the quiet school of evolution. Other fish join in this vanishing act. Lanternfish, for instance, swim in loose shoals, their ventral lights tuned to erase the shadows their bodies would otherwise cast. This is not the flickering lure of the anglerfish or the sudden burst of a startled jelly. It is a steady, measured light, one meant to leave no trace. The effect is meditative to imagine. Schools of small silver fish drifting in the midwaters, bellies glowing softly, erasing themselves from the gaze below. They are there, but they are not there. The ocean becomes a theater of illusions, a place where survival is a matter of matching not just the color of your surroundings, but their light signature. And there is something poetic in this, the idea that light, which we so often think of as revelation, can be used for concealment. It is the paradox of glow, to shine so that you might disappear. If you were to float alongside such creatures, perhaps as still as they are, you might feel the pull of that same instinct, to become part of the background, to let yourself blend into the fabric of the sea until even the darkness forgets you are there. Above, the moon sways behind thin clouds. Below, shadows drift in the slow current. And here, in the middle, life writes its survival in the language of borrowed light. The ocean moves on, slow and deep, carrying these masters of invisibility with it. They leave no trail, no flash, no beacon, only a soft, perfect match to the world around them. In this quiet disguise, they endure. Step out of the water, and the glow changes its voice. No longer filtered through leagues of salt water, no longer shimmering in shifting blues. Here, on land, the glow is warmer, more intimate. It drifts between the trees, hovers over meadows, and pulses in the stillness of summer nights. The most familiar of these earthbound lights is the firefly, or lightning bug, though the truth is they are neither made of fire nor bugs in the strictest sense. They are beetles, small and unassuming by day. But when the sun dips and the air cools, they rise into the air like drifting embers, each one carrying a lantern made not of glass and oil, but of chemistry and evolution. In their abdomens, fireflies mix luciferin, a molecule whose very name means light bringer, with an enzyme called luciferase, in the presence of oxygen. The result is light without heat, efficient and clean, far better than the hottest filament or brightest bulb we have made. Nature has been running a perfect green energy lighting system for millions of years, one so efficient it wastes almost nothing in warmth. But this light is not for illumination, it is a language. Fireflies flash to signal to one another, each species with its own rhythm and code. A male might sweep through the air in a slow arc, his abdomen blinking in a measured pattern. A female, waiting on a leaf below, may answer with a smaller flicker, a silent yes that carries across the dark. Some flashes are simple greetings. Others are elaborate courtship dances, each one an unspoken poem in light. If you watch closely in a forest clearing, you might notice that some fireflies seem to flash in unison, whole clusters pulsing together like a breathing starfield. This is synchronous flashing, a phenomenon still not fully understood, though scientists suspect it may help the group coordinate and attract mates more effectively. To the human eye, it feels like magic, as though the forest has found its own heartbeat. Fireflies are not alone in their terrestrial glow. Certain fungi also cast their own quiet light, especially in the damp forests of Asia and South America. Known as foxfire or fairy fire, these fungi glow from within their decaying wood, casting a pale green light that can be seen on the darkest nights. Some believe this light attracts insects that help spread the fungus's spores. Others think it may deter animals from eating it. Either way, it is an old and patient glow, not the quick flash of an insect, but a steady candle in the forest floor. And then there are the stranger sparks, millipedes that glow to warn predators of their toxicity, earthworms with luminous mucus, even tiny springtails whose bodies glimmer faintly in the underbrush. Their glow is not for beauty or romance, but for defense, a quiet warning. I am here, and I am not worth eating. Unlike the ocean, where light often feels like a vast cosmic signal, on land it feels close, personal. A firefly's flash is meant for one specific other, a single spark traveling through the night air like a love letter. A glowing mushroom may shine for weeks without moving, its light spilling only into the small patch of leaves around it. And perhaps that is why terrestrial glow feels different to us. In the deep ocean, the light is survival against vastness. Here, it is survival against intimacy, predators close enough to touch, mates close enough to see you. These small sparks write their purpose in a world where distances are short, and every glow is noticed. In the stillness of a summer meadow, the air warm on your skin, you can watch them rise and fall, these tiny lanterns of life. Each one is a note in the quiet music of the night, a reminder that even in the smallest corners of the world, nature keeps a little light for itself. Step into the forest after dark, and the familiar shapes of the day dissolve. The path you knew is swallowed by shadow. The trees, those towering columns of green and bark, become silhouettes against the faint gleam of starlight. The air feels heavier here, not from danger, but from an ancient hush, as if the forest itself is holding its breath. And then, just when your eyes begin to adjust, you notice it. Not moonlight, not a stray lamp, but something subtler, stranger. A faint greenish glimmer from a fallen log. A tiny bead of light on the side of a tree. A cluster of points, low to the ground, like a constellation trapped in moss. These are the hidden forest glows, life forms that light their own corners of the night. You could walk this trail 100 times in daylight and never know they were here. Their presence belongs to darkness. One of the most enchanting comes from glowworms. Despite the name, glowworms aren't worms at all, but the larval stage of certain beetles and flies. In the cool understory of forests, they set small, glowing traps. If you look closely, you might see strands hanging like dew-streaked silk, thin threads coated in droplets, glistening faintly. In truth, these are sticky lines designed to catch tiny insects. The glow at the worm's tail draws them in like moths to a flame. And when an unsuspecting insect drifts too close, it brushes one of the sticky lines and becomes dinner. In some caves and rainforests, glowworms work on a grander scale, forming star fields of light across ceilings and rocky walls. But in the forest, their work is humbler, quieter, a small lantern to lure a meal in the night. Then there is foxfire, the ghostly light of bioluminescent fungi. Unlike the quick, pulsing flash of a firefly, foxfire shines with a steady glow, often in pale green. The light comes from the mycelium, the branching, root-like network of the fungus, as it digests rotting wood. Scientists think the glow may attract insects that help spread the fungus's spores, though it may also be a byproduct of detoxifying chemicals in the decaying wood. In some parts of the world, foxfire is bright enough to read by, though you'd have to crouch close to the log and let your eyes adjust. In other places, it's only a faint suggestion of light, barely there, yet enough to stir the imagination. Folklore has long wrapped itself around foxfire. In Japan, it was once thought to be the work of mischievous fox spirits. In Europe, it earned names like fairy fire or will-o'-the-wisp, blurring the line between biology and myth. And there are stranger lights still. In the Appalachian forests of North America, you might stumble across a species of millipede that glows with a soft blue-green, warning predators of its unpalatable chemistry. In the mangrove forests of the tropics, certain click beetles lift their heads to reveal twin glowing spots that resemble eyes, an eerie, floating gaze in the darkness. Some tropical termites build towering mounds that seem, at night, to be freckled with glowing dots. These are the lights of fungus gardens within, where symbiotic fungi grow on plant matter collected by the termites. While the glow's purpose is still debated, one theory is that it lures in flying insects that blunder into the mound, becoming extra protein for the colony. And then there is the smallest forest glow of all, microorganisms, barely visible to the naked eye. Certain soil bacteria carry bioluminescent genes, and in damp, rotting wood they can emit a faint, cold light. If you were to hold the log in your hands and look closely in total darkness, you might see a shifting pattern of tiny sparks as the bacteria spread. What's fascinating is that many of these land-based glows evolved independently of one another. A firefly's light, a fungus's glow, a millipede's warning, all come from different biochemical paths, yet converge on the same result: visible light in the dark. Nature, it seems, has a fondness for the luminous. And yet, most forest glow is invisible to the casual hiker. You have to let the night become your guide. You have to slow down, stop, and let your eyes pull in every photon they can. You have to wait long enough for the greenish halos to emerge from the blackness. The forest teaches you patience, and in return, it shows you its lanterns. Some scientists think these glows once played larger roles in ancient ecosystems, signals for finding mates, lures for prey, deterrents for predators. Others suggest they could have been accidental, a side effect of metabolic reactions that just happened to be visible. Either way, They persist, scattered across the planet's wooded places like forgotten lanterns in the undergrowth. And when you see them, whether it's a single bead of light on a wet log or a whole hillside of glowing fungi, you feel something shift. These are not city lights or stars or even the rolling glow of the sea. They are the Earth's own quiet signatures, written in the ink of night. In the hidden glows of the forest, you see not just biology, but continuity, a reminder that life has always been reaching into the dark, testing the air with light, finding ways to be seen. In the deep ocean, where the pressure is crushing and the darkness eternal, danger often arrives without sound. A shadow moves where no shadow should be. A current shifts in a way that feels unnatural. And in these moments, when the hunter draws near, some creatures do not run, hide, or fight. They shine. It is a strange defense to call attention to yourself when your life depends on being unseen. But in the abyss, light can be as startling as a shout in a silent cathedral. When the deep-sea jellyfish Atala wavilii feels a brush from an approaching predator, it bursts into a spinning wheel of blue light. The sudden halo radiates outward, like ripples in water made of photons instead of waves. It is a beacon, a cry for help. The flash might startle the attacker long enough for the jellyfish to drift away, or it might lure in a bigger predator to chase the first one away. In the darkness, surprise is a weapon. Some animals take this one step further, creating luminous smoke screens. Tiny crustaceans, barely visible even in daylight, can eject clouds of glowing chemicals into the water. A predator rushing in for the kill finds itself suddenly surrounded by a swirling mist of light. It is not a solid thing, not something to bite, but it fills the senses, dazzles the eyes, and turns the hunter's precision into confusion. By the time the light fades, the prey is gone, carried away by slow-moving currents. This is nature's version of a flare thrown into the night sky, not to signal rescue, but to signal danger. In the deep sea, the language of light is as layered as any spoken tongue. Elsewhere in nature, the same principle repeats in different colors and forms. On land, many poisonous frogs wear vivid skin, electric blues, blazing yellows, fire reds, their bodies warning, "Do not touch me. Do not taste me. I am dangerous." The glow of some marine life plays a similar role, except here, the color emerges from within, and it speaks in pulses and glimmers instead of pigments. The difference is profound. Pigments are permanent. A poisonous frog cannot turn its color off. But light is choice. Light is a message that can be sent or silenced, shaped into a sudden flash or a slow, rhythmic pulse. In the ocean's darkness, it can be both invisible until needed and overwhelming when unleashed. Some bioluminescent warnings are not about startling, but about branding. Once a predator has tasted something unpleasant, a specific light pattern might be remembered and avoided. This is the slow writing of survival into the mind of the hunter. One bad meal, and the memory glows there forever. The ocean is not alone in using light to deter. Fireflies, for example, are sweet to look at but bitter to taste. Some species flash not just to find mates, but also to tell would-be predators, "You will regret this." And predators learn. It is a curious thing that across the branches of life, from single-celled plankton to jellyfish, shrimp, insects, and beyond, light has been reinvented over and over again as a form of refusal, a gentle but firm stay away. In the abyss, where no sunlight penetrates, this refusal can look like beauty. The predator sees not just a prey item, but a sudden bloom of alien radiance, a pattern that breaks the monotony of black. It is a moment that can confuse, dazzle, and halt. Sometimes, in the ocean, beauty itself is a shield. And perhaps this is why, when we look at such creatures from the safety of our world, we do not think of fear or escape, we think of wonder. We watch videos of glowing jellyfish spiraling through black water, and we see art. But for them, it is not art. It is survival written in light. The night ocean is full of these unspoken negotiations, between predator and prey, between hunger and fear, between the choice to be seen and the need to disappear. And when a creature chooses to shine as a warning, it is choosing to risk being noticed in the hope that the right message will be understood. I am not worth your pursuit. Light, in this way, becomes more than just vision. It becomes a conversation in the dark. A sudden flare says, "You are not welcome here." A slow pulse says, "I am not the meal you seek." And in the endless midnight of the deep, where the only certainty is uncertainty, those who speak light fluently stand a better chance of surviving another tide, another night. Because down there, warning is not always about shouting the loudest. It's about shining at the right moment, with just the right glow. The ocean is an old storyteller, and light has been one of its favorite tales. Across the vastness of time, in corners of the sea so far apart they could never meet, life has found a way to make itself glow. Not just once, but again and again, at least 40 separate times that we know of. Each time, a different species stumbled upon the same strange magic, the ability to summon light from darkness. Why? Why would the same idea emerge so often in creatures that share nothing else in common? This is the riddle of convergent evolution, nature's way of showing that when something works well, it will be rediscovered again and again, as if the blueprint is written into possibility itself. Bioluminescence is not the legacy of a single ancestor passed down the tree of life. It is a repeated invention, as if light itself whispers to living things, "You could use me." And life listens. In the deep sea, the darkness is nearly perfect. No sunlight reaches the midnight zone, no glimmer from the surface. Down there, light is not decoration, it's survival. It can lure, it can warn, it can disguise, it can seduce. In a place where energy is precious and life is rare, bioluminescence becomes a multi-tool, reshaped to fit the needs of whoever wields it. Picture an anglerfish, dangling its glowing lure in the black. The light is a promise of food to smaller fish, and by the time they realize the promise is a trap, it's too late. Now picture a shrimp that responds to an approaching predator not with speed alone, but with a sudden, cloud-like burst of glowing fluid, confusing the attacker long enough to escape. Two very different creatures, two very different uses, yet both arrived at the same solution, light. This is the quiet brilliance of convergent evolution. The deep-sea squid that blinks in complex patterns, the firefly that flashes in a meadow, the glowing bacteria that make a fish's skin shimmer, they are not cousins in a glowing family tree. They are strangers who learn the same language. In biology, certain problems appear again and again. How do I find food in the dark? How do I avoid becoming someone else's food? How do I find a mate when I cannot see them? Light, it turns out, can answer all three. In the open ocean, where there are no rocks or trees to hide behind, camouflage can mean becoming invisible against the faint light from above, a trick called counterillumination. In the forest at night, it can mean signaling to a mate from a distance, without attracting unwanted attention from predators who cannot interpret the signal. For bacteria, it can mean convincing a host to keep you close, rewarding them with a glow that attracts prey to both. Nature reuses this strategy because light is not bound to one single purpose. It can shift from weapon to shield to invitation with the smallest change in timing or color. It's like music. You can take the same notes and make a lullaby, a warning call, or a love song. Scientists studying the origins of bioluminescence have traced it back hundreds of millions of years. Some of the earliest glowing organisms may have used it simply to protect themselves from harmful oxygen. The chemical reactions that create light can also neutralize oxygen's damaging effects. What began as a shield might, over countless generations, have been adapted into a lantern. Perhaps that is why bioluminescence has been invented so many times, because its beginnings are humble, but its possibilities are endless. It also reminds us that evolution is not a straight line, but a restless tinkerer. It works with what is at hand, reshaping old tools for new challenges. Sometimes, that means turning a molecule that once fought oxygen into a beacon that lures dinner. And while each invention of light is separate, they all share something deeper, a physics that is constant, a chemical truth that never changes. Across species and eons, the glow comes from the same essential dance. A molecule called luciferin meets an enzyme called luciferase. Oxygen joins the meeting, and light is born. The names are ancient and poetic, luciferin, meaning light bringer. Yet the process is chemistry at its most efficient. Nearly all the energy goes into light, with almost no heat wasted. Humans have never built a light source so perfect. In this way, Bioluminescence is both ordinary and miraculous. Ordinary, because it follows the same chemical laws no matter where it appears. Miraculous, because life keeps rediscovering it, as if the dark keeps asking the same question and light keeps answering. When you think of evolution, you might imagine it as a slow painter, adding detail stroke by stroke. But sometimes, it is more like a sudden flash, a moment where nature stumbles upon an idea so useful, it echoes across continents and centuries. The ocean's abyssal fish, the meadow's fireflies, the cave's glowing worms, they are all proof that some ideas are too good to stay hidden. Evolution keeps the lights on because in the long, patient game of life, light is never just light. It is survival, communication, attraction, deception, all written in photons. And maybe, in a way, evolution keeps the lights on for us, too, so that one day, far in the future, we would sit here in the quiet and tell their story. From the ocean's depths to the quiet hum of a laboratory, light's story continues, no longer confined to the cells of jellyfish or the drift of plankton, but translated into glassware, circuitry, and the hands of human curiosity. It began, perhaps, with wonder. A scientist kneeling by a tide pool, watching the water glow as footsteps disturb the sand. A child catching a firefly in a jar, seeing the flash and wondering how it works. That ancient question, how, has led us to borrow from nature's toolkit, to use the glow that once belonged only to the wild. One of the most profound gifts we've taken is the green fluorescent protein, or GFP. First found in the crystal-clear jellyfish Equoria victoria, this protein was nature's own chemical lantern. In the 1990s, scientists learned to insert the gene for GFP into other living cells, not to make them pretty, but to make them visible. Inside the dim forest of a cell, proteins are like shadowy travelers. With GFP, we can watch them move, gather, or vanish in real time. The glow became a language, telling us secrets the microscope alone could not. In neuroscience, bioluminescent proteins help us trace the electric pathways of the brain. A thought is nothing more than a pattern of signals, fleeting and invisible, unless you tag it with light. In medical research, glowing markers can reveal where cancer cells hide, how infections spread, or whether a new treatment is working. What was once a lure for deep-sea fish now guides surgeons' hands with pinpoint precision. And in environmental science, bioluminescence is our silent sentry. Some researchers place glowing bacteria in water samples. If pollutants are present, the glow fades, giving an instant, living signal of contamination. No machines, no wires, just life responding to the world, as it always has. There's poetry in this loop, life creating light, and light revealing life. A shrimp's defensive cloud in the midnight sea is not so far from a lab dish glowing green under ultraviolet rays. Both are messages. Both are survival. When we hold a vial of glowing liquid under a microscope, we are looking at the same principle that made a firefly's abdomen glow 100 million years ago. The same physics that lets starlight travel across galaxies is harnessed in a droplet of jellyfish protein to map the human brain. It is humbling, and perhaps comforting, to know that our most advanced tools are often echoes of something nature mastered long before we arrived. The hum of the laboratory is steady, almost like a distant tide. A pipette clicks softly. The glow under the lens is pale, but resolute. You imagine the ocean outside, black and infinite, carrying its own silent experiments in every current. Light is not bound to a single place or a single purpose. It has crossed boundaries, from predator's lure to scientist's beacon, from ocean's depths to hospital room. In this way, bioluminescence reminds us that discovery is not about owning nature, but about listening to it, watching the glow, learning its grammar, and then speaking it in new contexts, to heal, to protect, to understand. And still, in the dark waters somewhere far below, a jellyfish drifts, unaware that its shimmering body has changed the way we see the invisible. If you trace every glow back to its beginning, you arrive at the same source, light born in the heart of the universe. A star ignites, its fusion forging brilliance that spills into the dark. Across billions of years, that light travels, scattering through gas clouds, glancing off dust, touching the surface of a distant ocean. And there, in that water, In the quiet churn of life's chemistry, a cell learns to keep a spark for itself. The physics that makes the sun blaze is the same physics that makes plankton shimmer in the wake of a boat. The glow of a firefly's abdomen on a summer night and the flare of a galaxy a million light years away both obey the same laws of energy, electrons, and photons. One is vast, the other tiny, yet they speak the same language. When we see bioluminescence, we are watching matter transform, just as stars do. The scale is different, but the principle is shared. Light as a message, light as a bridge between here and elsewhere. In this way, the glow becomes more than a survival trick. It is a reminder that all life, glowing or not, is stitched together by the same cosmic thread. We breathe air forged in ancient stars. We drink water older than the mountains. And when we witness a jellyfish pulsing in the dark or a beetle flashing in the grass, we are seeing a fragment of that original fire, repurposed by evolution into something delicate and alive. It is easy to forget this, to live under electric lights and glowing screens, believing that light is ours to switch on and off. But the truth is, we inherited it. Every photon that touches your skin tonight began its journey long before there were eyes to notice. The ocean knows this truth. So does the forest. So do the small creatures that spend their brief lives sparking against the dark, carrying their own kind of eternity in a single blink. You, too, are made of stardust, the same dust that makes galaxies shine and plankton glow. That is not just poetry, it is chemistry, unshakable and exact. So the next time you see a faint shimmer in water or the flash of a firefly in the warm air, pause. Let it remind you that you live in a world where light can hide in a cell, in a seed, in a memory, and that you are part of the same equation. From the sun's first rays on Earth's young oceans, to the quiet bioluminescent drift of the midnight zone, to the laser-precise glow of proteins in a lab, light has been traveling toward this moment, toward your awareness. The glow connects us not only to nature, but to time itself. It is a reminder that we are woven into the long story of the universe, a story told in photons and in breath, in the glint of the Milky Way and the spark in a living cell. And in that story, your place is here, watching, wondering, carrying the memory of every glow you have ever seen into the dark, until it becomes part of your own light. And so, we return to the quiet. From the ocean's hidden depths to the forest's silent floors, from the small sparks of insects to the grand blaze of stars, we have followed the glow wherever it led. We have seen it as a lure, a warning, a beacon, a secret language whispered through the dark. Every shimmer we encountered was not just a trick of nature, but a reminder. Life is a conversation between darkness and light. The deep-sea plankton, the drifting jellyfish, the firefly in your garden, they are all part of the same ancient story, one that began before our world had a name. As you close your eyes, let these lights linger in your mind. Imagine them drifting together, joining the great constellation of memories, until they form a gentle map you can carry with you into sleep. The night may seem vast, but it is never truly empty. Somewhere, even now, something small is glowing, quietly, patiently, waiting to be found. And perhaps, in your dreams, you will walk toward it.